Hello everyone, in this video I'm going to focus on homework 6. On this homework, 3 datasets are given and I'm going to focus on healthcare dataset. Okay, so let's get started with the first question. So in a healthcare dataset, which looks like this, so each row represents a patient, so we have some information for our patient, the year of birth, ethnicity or race, height, weight, systolic blood pressure, and so on. So these are the information of 100 patients. So actually a sample size or the number of rows or the number of patients is equal to 100. So we have got the information of 100 patients or individuals. All right, so the first set of questions that we have here is related to the expected value and count. Okay, so we need to create a cross table or cross tabulation of ethnicity, race, and insurance status. Okay, so in fact, we have a table which we have a table with two variables. The first variable is ethnicity, race, and the second one is insurance status. So the table that we get from the SPSS is going to look like this. I show you how we can get this table, but before that, so before to discuss about this table, how we can get this table from SPSS, so I want to show you how we can get these numbers that are giving this table from the Excel. So like I mentioned in previous videos, for homework 2 and 3, we use if conditional statement. So now let's say I'm interested to find the number of Asian people who are using private insurance, right? So I'm looking how many Asian are using private insurance. So this is some kind of question that I want to answer. Again, how many Asian are using private insurance? So I need to look at the ethnicity, okay? So because ethnicity, race gives me Asian, a different type of race, and also I'm going to look at the insurance status because I'm looking for private. Okay, so I can use count ifs. So since I'm using two conditions, so I'm going to select count ifs. So the first condition goes under ethnicity, race. So I'm going to select the range of ethnicity, race column. Okay, and comma. So that's range. The second, the second input argument is the criteria. Like I mentioned, I'm looking for Asian people, so my criteria goes inside the quotation. So I have an Asian here. Okay, so that's the first criteria. So I'm looking for Asian who are using private. The second condition is private. So I need to look at the insurance status column. So I'm going to select the insurance status column. So the last input argument that I have is comma. So I'm looking for those people who are using private insurance. So make sure you do not have any misspelling, otherwise you get 0. Okay, so I got 9. What does this tell me? It tells me there are 9 people who are Asian and using private insurance. So now let me change these. So I'm going to change these parameters, input arguments. So let's say you are looking for those Asian who are on Medicaid. So Asian is right here. So I'm going to change the second conditions to Medicaid. So I'm looking for those people who are Asian with Medicaid insurance. So I'm going to hit enter. So there are 11 Asian who are using Medicaid insurance. So this is how you can uh, find the intersection of ethnicity, race, and insurance status. But just imagine we have three level of insurance status: Medicaid, uninsured, private, and we have different type of races. And every times if I want to find, let's say I want to find Asian Medicaid, Asian uninsured, Asian private, and then we have Latino Medicaid, Latino uninsured, Latino private, right? So that would be very time consuming. So the alternative solution is to use pivot table. So pivot table is very useful. So we can use pivot table to answer all these type of question. So I'm in order to use the pivot table, so I'm going to select my table. So I select my entire table. As you can see, my entire table has been selected. And then I go to the insert and I click on pivot table. So I want to generate a pivot table in a new worksheet. So now I need to specify what is my column and row. So your column could be ethnicity, race, and your row could be insurance status, or vice versa. It doesn't matter. So I'm going to choose ethnicity, race, drag it to the column. So my column represents the ethnicity, and my insurance status represent the rows. And I can use ethnicity, race as a value. So if I click here, so there is a value field settings. So I'm going to set it to count because I want to count the number of let's say Asian who are using private, or Caucasian who are using uninsured. So that's why I'm going to set it to count. By default, Excel is use count. Sometimes you want to find the average, so you can change it to average. But in this assignment, we're going to look at count. So now let's look at the numbers here. So let's interpret these numbers. So these numbers, let me highlight it with the yellow. So this number is 9. So this 9 comes from the intersection of private and Asian, right? The intersection of Asian and private gives me this value 9. So what does this tell me? It tells me we have 9 Asian who are using private insurance. How about this number? So let's look at this number 4. This comes from intersection of uninsured and Hispanic or Latino. So it tells me there are 4 Hispanic who are uninsured. So this is how you can make a interpretation. So this number comes from table, right? So we have calculated this number using if conditional statement. If you guys remember, so we calculated here, we say that count ifs, then we selected the range of ethnicity, race, comma, Asian, and then we selected the range for insurance status, comma, private. So it tells me 9. So I did it in 2 minutes ago. So this is exactly, we can calculate the number of Asian people who are using private using count ifs statement. So like I mentioned, there are 2 methods. You can use count if or count ifs statement. So because we have 2 conditions, we are going to look at Asian, the first condition, and also we're going to look at the private. So 2 conditions, we are going to use count ifs. So it gives me 9. So there are 9 people who are Asian and using private insurance. Okay, so now let's look at these numbers. How many African and American do I have in my data set? 25. How many Asian people do I have in my data set? 25. Caucasian, so 25. Hispanic, 25. So 25 plus 25 plus 25 plus 25, I've got 100. So this 100 is my sample size, or the total number of rows. So I have got 100 patients or 100 people in my data set. So if you guys remember, this is kind of data set that we used in the past. So we have started from row 2. Okay, so that's the first patient or first individual, second individuals, all the way to 101. So in Excel, if you want to count it, so how many people do you have? So count. So you can count. You select this row, and you have got 100 people. So now let's say you want to count the number of Asian people, for example. So I can use count if. So I'm gonna look at the range of the ethnicity, race. Okay, so as you can see, that's the range of ethnicity, race column, comma. So I'm looking for the number of Asian. So my criteria, as you can see, the second input argument is criteria. My input argument or my criteria is Asian, because I'm trying to find the total number of Asian people. So as you can see, is 25. Okay, so if you do some misspelling, so you may get different numbers. So make sure you do not have any misspelling. So let's go back here. So where's the total number of Asian? The total number of Asian is 25. The total number of so we have 100 people, 25 people from each races, because I've got 4 races. Okay, so now let's look at the rows. So we have 3 type of different insurance: Medicaid, private, uninsured. So what is the total number of Medicaid? The total number of Medicaid is 43. The total number of private insured is 40 people, right? So 40 people have private insurance, 43 people have Medicaid insurance, and 17 people are uninsured, right? So if I want to, let's find these numbers. 17. So 17 represents the total number of uninsured. So I can use count if. So I can say equal count if. So then I'm going to look at the range of insurance status. Okay, so my criteria is uninsured. So because I'm looking for those people who are uninsured. So 17 people are uninsured. So this is how you can calculate. As you can see, 17 people are uninsured. So this is called pivot table. So 43 represent the total number of people with Medicaid insurance. 40 represent the total number of people who have private insurance, and 17 people total number of uninsured. So this 100 calls grand total. Okay, so it's called grand total, the total number of patients or individuals that we have in our data set, or the total number of rows, or we can call it sample size, or simply when it comes to the pivot table, we call it grand total. All right, so now so these numbers, let me highlight the numbers that we have in these cells. So these numbers that we have in these cells, let me highlight it with different colors, probably orange. So these numbers called count. Okay, so these numbers are called count. For example, we know that 11 people, so look at these cells. So these cells comes from the intersection of Asian and Medicaid. So we know that we have 11 Asian who are on Medicaid insurance, right? So let's look at this number 3. That comes from intersection of African American and uninsured. There are 3 African American who do not have any insurance. So now let's look at here, Hispanic, 9. So it comes from the intersection of Hispanic and private. So there are 9 Hispanic who are using private insurance. So these are the count. As I show you here, we use count ifs to find those number of people with a specific race who are using a specific insurance type, right? So these are called count. So we have another terms, it's called expected count. So now let's calculate the expected count for Asian and private. So now the question is, what is the expected count or number of people? So you can say count or number of people who are Asian and use private insurance. So we want to calculate the expected count. Okay, so let's use this note. So again, so we are looking to calculate the expected number of people who are Asian and using private insurance. Okay, so here are the two keys. So we are looking at Asian people who use private insurance. So how we can calculate the expected count? So this is the general formula. So expected count of I and J. So I represent here, let's say, I can say, let's go back to here. So I can assume that I is my column and J represent my rows. Okay, so you can say I represent my column and J represent my rows, right? So how many rows do I have? I've got 3 rows: Medicaid, private, and uninsured. So J, which represent my number of rows, so J could be either 1. J equals to 1 means Medicaid. J equals to 2 means private. J equals to uninsured, or 3 means uninsured, right? J equals to 3 means uninsured. So I can assume that I represent the number of columns. The number of columns. So how many columns do I have in this specific example? So I have got 4 columns. Why? Because I have 4 type of races. So I equals to, that should be not a capital I. Okay, so now I equals to 1. That means the first race, African American. The second column is associated with I equals to 2. I equals to 3 refers to the third type of race. And I equals to 4 represent the last column, Hispanic. Okay, so now I'm looking for, let's go back to the question. I'm looking for Asian. So Asian represent, so Asian represent I equals to what? I equals to 2, right? Again, so I equals to 2 because Asian is a column, right? So the second column, the second column means I equals to 2. So I equals to 2 and J. So J represent the rows. So private, we are looking for those people who have private insurance. J represent the rows, and J equals to 2. J equals to 1, J equals to 2, J equals to 3. So I'm looking for private. J equals to 2 represent private. So this is how you can find I or J. So the expected count of I and J. So, or simply you can say, instead of I and J, you can say I equals to 2 means Asian, and J equals to 2 means private. You can just use the plain English instead of the notation. So expected count of I and J is equals to row total of I times column total of J divided by grand total. Okay, so now just for simplification, let me show you how we can do this calculation. So expected value, So the expected value of Asian and private. So I can say the Asian is what? So the Asian is my column and private is my rows. So the total number of Asian, so oops, the total Asian times the total number of people who are using private insurance divided by grand total. The grand total represents the total number of people who we have in our data set, or the number of rows. So this guy, this 100 represent grand total, right? The total number of rows, or how many people do we have in our data set or sample size, whatever you call it. So that goes to denominator. So the total Asian, so the total Asian, so here the total number of Asian is 25. So we have 25 from each race or ethnicity. So 25 from Asian. So I'm gonna plug here 25 times the total number of people who have private insurance. So the private total is 40, right? So there are 40 people who are using private insurance. So here we have 40. So if you do the math, 1000 over 100, so you will get 10, right? So the expected value of those who are Asian and using private insurance is 10. So what does that mean? It means that you are expecting to have 10 Asian with private insurance. But actually, in reality, okay, in reality, you do not have 10. So you have only 9 people who are Asian with a private insurance, all right? So count is 9, expected is 10, right? So look at here. So these numbers represent the actual count, right? So these numbers inside this pivot table represent the actual count of ethnicity given insurance type of insurance. So for example, in reality, when I'm saying reality, that means if we look at this table, so we have 9 people who are Asian, 9 people who are Asian with private insurance, but we are expecting to have 10 Asians with private insurance, right? So the count is 9, the expected is 10. So of course you can calculate the expected value of Asian uninsured, Asian Medicaid, African American private, African American uninsured, and others, right? So there are lots of calculation. So sometimes it could be very time consuming and it's not really efficient method to do all this calculation. So we can, so that's why we can use Excel, sorry, SPSS instead of Excel. So we can find all these expected value. So how we can do that? So we can go to the analyze. We go to the descriptive statistics and then cross tabs. So I can select a target list as a ethnicity race and column insurance status or vice versa. Okay, so and then I'm going to get a cross tab tables. So if I hit OK, so I got the cross tab tables. So again, some things that I forgot to mention. So when you go to the analyze descriptive statistics cross tabs, so make sure you click on cells and make sure you check the expected. By default, so you don't have any expected value, right? So observe is the count. So I show you. So these are observed values, right? So the number of 9 represent the number of Asian with private. So these numbers are observed. The pivot table in Excel gives us observed, but the Excel directly does not give us the expected count, right? So you need to calculate the expected count using this formula, okay? So, but SPSS gives us the expected value. So by default, the SPSS does not have expected. So you need to click on cells and check the expected value. Okay. So then hit OK. So I got the expected value. So now let's interpret this number. So we have 11 African American who are using Medicaid. So, but the expected count is 10.8. So I am expecting to have 10.8 African American who are using Medicaid. So now let's do the interpretation about this number. So okay, so this number 5. So the 5 comes from the intersection of uninsured and Caucasian. So there are 5 Caucasian race who are using who do not have any insurance. So now let's look at for example, this number 12, right? So we have this number comes from the intersection of Hispanic and Medicaid. So we have 12 Hispanic who are using Medicaid insurance, but the expected value is 10.8. So we can see some difference between count and expected count. Okay, so now we understand this table, cross tabulation, and we fully understand how it works, especially in Excel and also in SPSS. So now we can answer all these questions. So now let's look at the first question. Which race? Okay, so you need to read the question very carefully. Which race demonstrated the greatest difference between actual and expected counts? So we're going to look at the race, right? So rows represent the race. So, or you can set your rows to insurance status. It doesn't matter. So I select the ethnicity or race as my row. So I've got 4 rows: African American, Asian, Caucasian, and Hispanic, right? 4 different type of race. So I'm gonna calculate the difference between their count and expected count. So now let's answer the first questions. So what is the difference? Which race? So I've got 4 race. Which race has the greatest difference between actual and expected counts? So now let's focus on the first race. The first race is African American. Okay, so I'm gonna count the difference between 11 and 10.8, right? So I've got let me adjust this bar. Okay, so we have 11 African American who are on Medicaid. So that's the actual value, and the expected is 10.8. So what is the difference between these two, right? So I'm going to use absolute value, right? So if you have a negative number inside the absolute value, it makes it positive, right? -2, it turns to positive, right? So because we don't want to get anything negative, so that's why we are using absolute value. So 11 minus 10.8, right? So now we have some African American who are using Medicaid. Also, we have some African American who are using private. So what is the difference between those private and the actual value and expected value, right? Plus 11 minus 10. So finally, we have some African American who are uninsured, right? So I'm going to count the difference between African and American who are insured. So the difference between count and expected count of this category, right? African American uninsured. So the difference between count and expected value. So 3 minus 4.3. So that gives me 2.5. So this 2.5 is associated with this race, right? So because some of African American use Medicaid, some of them use private, some of them use for uninsured. So I'm going to look at each category. The first category is Medicaid African American. What is the difference between count and expected value? The second category, private African American, right? So those African American who are using private insurance, what is the difference between count and expected value? 11 minus 10. And similarly, I do for uninsured, 3 minus 4, 3. So now it's time to do the second race. Look at the question. The question is asking for the race. So we're going to look at these data in a row format. So now I'm going to do the same calculation for Asian. So some of Asians have Medicaid. So what is the difference between their count, actual count, and expected count? So 11 minus 10.8 plus 9 minus 10, 9 minus 10 plus 5 minus 4.3. So if you do the calculation, so here's the answer. I have the answer here for you. So the answer is 1.9. So Asian is 1.9. So you do for the other races. So here we have the answer. So 3.5 and 2.5. So 3.5 and 2.5. So this is 3.5. This is 2.5. So this race, Caucasian, so has the greatest difference, right? So because if you look at this specific race, the difference between count and expected value for different insurance is higher compared to the other races, right? So the answer would be Caucasian. Okay, so now let's do the second question. So the second question says, which insurance status, right? The first one says, which race? So we're going to look at the row because race represent my row. I'm going to look at the Asian, African American, Hispanic, right? So now I'm going to look at the columns because the question is asking which insurance status demonstrate the greatest difference between actual and expected counts, right? So this time I'm going to look at my insurance which represent the columns. So I'm going to look at the columns, right? So we have Medicaid for African American, Medicaid for Asian and other two races, right? So so let's do the calculation for Medicaid. So the Medicaid for African American, the count was 11. The expected was 10.8, right? Plus, so let's do different color. So the Medicaid for Asian, the actual count was 11. The expected was 10.8 plus. So another color. So for Caucasian, so Medicaid is 9 minus the expected is 10.8 plus. So finally, so we have a Medicaid for Hispanic. So the actual count is 12 minus the expected is 10.8. So if you do the calculation, so you can define the difference for Medicaid, right? So I guess we have answers somewhere here. I'm not quite sure. So probably in this slide, hopefully we have the answer here. Okay, so the answer is 3.4. So that's a difference for Medicaid. For private is 4 and the uninsured is 3. So if I have done this calculation correctly, so make sure you do the calculation correctly. Don't trust on me. So maybe this calculation is not correct, so you have to double check. So the private has greatest difference, right? So 4 is greater than 3.4 and 3, right? So the private insurance has the greatest deviation in overall. So that is the question to this number, the answer to this question. So which pair of race and insurance, right, had the greatest difference between actual and expected value, right? So again, read this question very carefully. Which pair of a race and insurance? Let's go back to pivot. So this is a one pair, African American Medicaid. This is another pair, Asian Medicaid. So this is another pair, Caucasian and Medicaid. So this is another pair, Asian uninsured, right? So now what we are going to do, so you are going to look at the, first start with African American and Medicaid. So what is the count, actual count, and expected count, the difference between these two. So then you move to African American private. So you're going to find the difference between actual value and expected value. Then you're going to look at the African American and uninsured. So you're going to find the actual count and expected value. What is the difference between these two, right? So you're going to do for every pair, right? So how many pair or how many cells do we have? So I've got 4 columns or 4 races and 3 insurance status. 4 times 3, so we have 12 cells or 12 cases or 12 pairs, so whatever you call it. So now let's do this. So I'm gonna find, so let's go back to this slide. I think it would be easier. So I'm gonna find the difference between these two, right? So the difference between these two, again, we are going to use the absolute value to avoid getting negative, to avoid getting negative number, because the negative is meaningless. So 11 minus 10.8 is 0.2. So the difference between count and expected value for those African American who are using Medicaid is 0.2. So now let's do the similar for those African American who have a private insurance. So the difference is 11 minus 10, the difference is 1. How about this guy, 3 minus 4.3? So the difference is 1.3. Okay, so now let's do this. So 11 minus 10.8. So this pair represent Asian and Medicaid. So the answer is 0.2. Another pair that I have here is Asian who are using private. 10 minus 9 is 1. So another pair is uninsured Asian. 5 minus 4.3. So the answer is 0.7. So now let's look at here, 9 and 10, 0.8, Caucasian and Medicaid. So the answer is 1.2. So here the difference is 1, the difference is 0.7. So the difference is 1.2, the difference is 1, and the difference is 0.3. So that's the difference. Make sure you calculate it correctly. So we found the difference between each pair, right? The difference between count and expected value, and we are going to pick the biggest number. So the biggest number is these two, right? So these two gives us the biggest number. So these two comes from the intersection of Medicaid, right? Caucasian and Medicaid, Hispanic and Medicaid, right? So these two pairs gives us the biggest number. Caucasian are using Medicaid, Hispanic who are using Medicaid. Okay, so I think I have the answer here. Let's double check to make sure I do not have any mistake. Okay, so Caucasian Medicaid, I guess that is, let's see, I have done some mistake apparently. So Caucasian Medicaid. So let's go back here. Caucasian Medicaid. Okay, so that's my mistake. So this is not 1.2. So the difference between 10.8 minus 9 is 1.8. So here we have 1.8. Okay, so here's the answer. The biggest difference comes from this pair. Those who have Caucasian race and using Medicaid, so that is the biggest number. And the least, so another question is asking for the least or the smallest. Somewhere it's saying as the greatest difference. Okay, and the next question is asking for the least difference, the minimum. So maximum, minimum number, maximum number and minimum number. So the maximum and minimum, so I believe this gives us, these two gives us the smallest number. Okay, so African American who are using Medicaid, so that's the greatest difference. And the smallest difference comes from African American who are using Medicaid. And because we have got two answer, right, two pairs, so 11 minus 10.8, 11 minus 10.8, also Asian and Medicaid, those who are Asian and using Medicaid. So these two groups gives us the smallest difference, and this group gives us the greatest difference. So this is how you can answer the questions. And the last question, so I have an answer for the last question here. So let's look at here. Given what you figured, what relationship between race and insurance status grab your attention? So of course, we look at Caucasian Medicaid because it has the biggest difference, right? So the biggest difference between actual count and expected count comes from this group. African American and Asian groups align very closely together because they expected Medicaid enrollment. It does not have any skew. The private insurance deviation through relatively balanced across races. So if we look at the private insurance, so here's the key. So we are going to look at only on private insurance column across different races, and we found some consistency. So this is something that you can mention, and this may imply underlying demographic and social economic influences on insurance type. So the idea is that so we're gonna okay, so what we can make an interpretation. So we are going to look at the races. So the largest number, the biggest number comes from Caucasian race, right? So that's the biggest number, 3.5. So that means we have a huge deviation when it comes to the Caucasian race. But if we look at the type of insurance itself, right? So the type of insurance itself, those people who are insured, regardless what kind of race they have, we have the lowest, smallest deviation, but the biggest deviation comes from private, right? So regardless of what kind of race you have, when you are using private insurance, the deviation would be largest, right? So we have largest deviation in terms of private insurance. So regardless of the race of the people. So this is how you can make an interpretation. So that's pretty much about the first section of this assignment. So in the next video, so we're going to continue with the second part of this assignment. So we will discuss the second part in the next video.